Hi. Alright, let's take up the next question. This was posted by your friend Kundan Kumar, and as you can see, the question is on syllogisms. Right? So we've got three statements and three conclusions. Let's draw the basic diagram for the given statements. The first one, some animals are flowers. Some animals are flowers. Animals and flowers. As you can see, this intersection indicates some animals are flowers. Many flowers are birds. Now here is an interesting word, many. Remember, many flowers are birds is as good as some flowers are birds. Some can be, in the context of syllogism, some has got many synonyms, right? Like many, a few, right? Most. All these are the same meanings of some, right? Sometimes they use percentages also. 94% flowers are birds, or 13% flowers are birds, or let's say 3.5% flowers are birds, or 47 flowers are birds. All those would mean some. Yeah. So many flowers are birds would mean some flowers are birds. Some flowers are birds. Again, many flowers are birds does not mean that you have to draw a bigger bird set to indicate many flowers are birds. Some intersection should be there. Whether it is this much or a bigger intersection doesn't make any difference. Right? So many flowers are birds or some flowers are birds. And the last statement is no animal is bird. I think we've got already animals and birds in the diagram, and no animal is a bird is also satisfied. Animals and birds do not touch each other. So here's the basic diagram. Simple. Some animals are flowers, indicated by this intersection. Many flowers are birds, which is some flowers are birds, indicated by this intersection. And no animal is a bird. Yeah, these two cannot touch each other. Let's now look at the conclusion. The first one. Some flowers are not birds. Some flowers are not birds. Well, if you have solved enough questions on syllogisms, you would know that some flowers are not birds is true. How can I say that? It is always true, moreover. How can I say that? See, we know that there is an overlapping between flowers and animals. Because some animals are flowers. In any diagram you draw, some flowers will be there which are animals. And animals cannot be birds. Animals cannot be birds. Statement says animal is not a bird. No animal is a bird. Meaning, there will always be some flowers which are animals. And such flowers cannot be birds. So there will be some flowers always which are not birds. You getting it? Some flowers are animals, but animals cannot be birds. Meaning those flowers which are animals can never be birds. So some flowers are not birds is always true. I don't even have to worry about possible diagrams. It will always be true. Right? Some flowers are not birds. Some flowers are not birds. Next, no flowers in animal. No flowers in animal. In the basic diagram itself, it fails. In the basic diagram, what did we see? Some animals are flowers. If some animals are flowers, how can we say no flowers in animal? In fact, diagram also is not required. No animal is a bird. Some animals are flowers. For some animals are flowers. The moment we know some A's are B's, we can say that no A is B or no B is A is wrong. Because some animals are flowers. When some animals are flowers, some flowers are animals. If some flowers are animals, how can you say no flower is an animal? So, conclusion number 1 follows, conclusion 2 does not follow. Now look at conclusion 3. Some animals are not flowers. This is some not type of conclusion. Be careful. Some animals are not flowers. Well, if you look at the basic diagram, you will find that some animals are not flowers. All these animals that are outside are not flowers. Does it mean that conclusion number 3 is true? No. It need not be true. Remember, this is a definite conclusion type. It's a definite type conclusion, right? It says some animals are not flowers. It satisfies the basic diagram, yes. But you have to check the possible diagrams also. When a conclusion is definite type, it should satisfy not only the basic diagram, but all the possible diagrams as well. Now, in this case, you may say, why didn't we check for the first conclusion then? The first conclusion satisfied the basic diagram. So we said it is true. No. I told you that any diagram you draw, you'll always have some flowers which are animals. And those flowers cannot be birds. Always, always. Any possible diagram you draw. That is the reason there is no need to check the possible diagrams. But in this case, conclusion number 3, you have to check possible diagrams as well. And I can imagine a possible diagram where this will become wrong. Let me show that possible diagram to all of you. I can think of a possible diagram where this conclusion will go wrong. See how? He says some animals are flowers. Can I not draw it in this way? Flowers and animals. Now you may say, he said some animals are flowers. We have drawn all animals are flowers. Remember, it's a possible diagram. It is possible to draw animals in such a way that all animals are flowers. This statement still holds true. Some animals are flowers. I can choose some of these animals. I can say these animals are flowers. Yes or no? So this is one way of drawing the statement. Some animals are flowers. Many flowers are birds. So some flowers are birds. And no animal is a bird. So animals and birds will not touch each other. We have drawn the diagram in such a way that none of the statements is violated. All the 3 statements have been followed. Some animals are flowers. Many flowers are birds and no animals are birds. Now check conclusion number 3. It says some animal are not flowers. We have got all the animals which are inside flowers. The moment all animals are inside flowers, how can we say some animals are not flowers? Some animals are not flowers become wrong here. That means conclusion number 3 is wrong. So conclusion 3 satisfies the basic diagram but fails in the possible diagram. Remember, a definite conclusion should be correct not only in the basic diagram but in the possible diagrams as well. Here this definite conclusion fails in the possible diagram. It fails in the possible diagram. Hence, conclusion number 3 is wrong. So your answer to this question should be only conclusion 1 follows. Only conclusion 1 follows. All roads are buses. All roads are buses. Draw the basic diagram. All roads are buses. No bus is a train. So no bus is a train. Bus and train would not overlap with each other. All the roads are buses and no bus is a train. Some trains are platforms. Some trains are platforms. Some trains are platforms. So there is some overlapping between trains and platforms. This is the basic diagram. And what is meant by the basic diagram? Minimum overlapping or minimum encroachment between different sets. Now look at the conclusion. The first one, some platforms are roads. Well, if you look at the basic diagram, some platforms and are roads does not satisfy, right? This particular conclusion, number 1 here, fails in the basic diagram itself. Some platforms are road. We clearly see that no platform is road. And the thumb rule is that if a conclusion does not satisfy the basic diagram, it is wrong. So we can conclude that conclusion number 1 is wrong, right? Some platforms are roads is wrong because it does not satisfy the basic diagram. Look at the second conclusion. Some trains are roads. Some trains are roads. This again does not satisfy the basic diagram, right? Does it satisfy? Some trains are roads? No. And it will never overlap. You do anything there. You draw any number of possible diagrams. Not even a single diagram will show an overlapping between trains and roads. Because we clearly know that buses and trains cannot touch each other. And roads are completely enclosed by buses. So if trains cannot touch bus, how will it go and touch roads inside that? So some trains being roads is impossible. So second one also does not follow. So then our answer should be neither conclusion 1 nor 2 follows. Okay. And these are definite conclusion types, right? Both are definite conclusions. These are not possibility types. If they were possibilities, we would have checked using possible diagrams, or we would have checked at least one diagram that could satisfy that. But a definite conclusion should satisfy all the diagrams. And both the conclusions here do not satisfy the basic diagram itself. Hence, both of them are false.